to the cloud. Most everybody is already EPA certified. I do have some updates. That because the other guys aren't here, they're going to miss out. So you're going to have to tell them we did talk about some updates. This is course 5, EPA requirements and refrigerant handling. All persons who maintain, service, repair, or dispose of appliances that contain regulated refrigerants must be certified in proper refrigerant handling techniques. If the EPA regulations change after a technician becomes certified, it is a responsibility of the technician to comply with any future changes. There's 4 categories of a technician certification. Type 1 is a person who maintains, service, or repair small appliances must be certified as a Type 1 technician. Type 2 is a person who maintains, service, repair, or dispose of high or very high pressure appliances. Now, just so you know, appliances, when the EPA first came out and used the word appliance, everybody thought that it was actually like a residential appliance, and technicians were like, good, I'm cool, man, I don't have to get certified, because they're only talking about appliances. In reality, that's the EPA lingo, their term for equipment or chiller or walk-in cooler. They deem it as an appliance. So whenever you see that word appliance, it means everything that we're working on. Very high appliances, except small appliances, motor vehicle, air conditioning systems must be certified as Type 2. Type 3 is a person who maintains, service, repair, or dispose of low pressure appliances must be certified as a Type 3 tech. And a universal is a person who maintains, service, or repair both high and low, as well as small appliances must be certified as universal. When I took my technician, my EPA test in the early 90s, it was a voluntary test through RSCS. There was no such thing as universal. It was just Type 1, Type 2. Type 3 was only for the automotive side. They didn't even offer it then. And it was, like I said, there was no such thing as universal. So for me, because I'm an older tech, all I have is my Type 1, Type 2. Gauge manifold set. One of the most important tools to the HVACR technician is the gauge manifold set. The compound gauge, or blue, and the high side pressure or high pressure gauge, red, are connected to the manifold. The manifold is then connected by hoses to access ports to measure system pressures. The compound gauge measures low pressure and vacuum. The high pressure gauge measures high pressure discharge or high side discharge pressure. The manifold is also equipped with a center port, usually a yellow hose, that can be connected to a recovery device, evacuation pump, or charging device. EPA regulations require that hoses be equipped with low loss fittings that will
Come on, Badger.
What's up? Hey, Nick. Jump right in here, bud. We're just getting into the meat of it. You good?
Yeah.
All right. You can see it okay?
I can.
There you go, bud. I'm glad you're here. Good morning. EPA regulations require that hoses be equipped with low loss fittings that will minimize refrigerant loss when hoses are disconnected. This is just a little side trivia again. If you notice the word compound gauge, technicians today are using the word analog, but an analog gauge is anything basically that goes from 0 to a positive pressure, and compounds are any gauge that can measure from 0 to into a vacuum, or from 0 into a positive pressure. So those are compound gauges. So when you see it used and techs are like, oh yeah, dude, I'm using my analogs, that's not always true, especially if they have gauges that go into a vacuum and into a positive. That's a compound gauge. Pressure is the force unit area, or force per unit area, most often described as pounds per square inch. Atmospheric pressure, or atmosphere, extends about 50 miles above the earth and consists of approximately 78% nitrogen, 21% oxygen. The remaining 1% is composed of other gases. Even though the gas molecules are very small, they have weight. The atmosphere exerts about 14.7 pounds per square inch at sea level. At higher altitudes, the atmospheric pressure is less. And it's been proven that if you go to Death Valley and you go to Badwater, which is the lowest point on Earth, I think it's minus 230 feet below sea level, it actually increases. The atmospheric pressure is increased because it's below sea level. Stupid trivia, sorry. The most common method of measuring atmospheric pressure is the mercury barometer. Normal atmospheric pressure at sea level is 14.7 psi. It will support a column of water of 29.92 inches. Mercury barometer. So I had a technician, this is kind of stupid, since the mercury is listed. I had a technician send me a box from Mississippi through my social media, and he so graciously sent me a bottle of mercury. So this is actually what the mercury barometer, this is actually what the mercury looks like in a very high concentration of mercury. It's a lot of mercury. It's the most that I've ever seen in a solid one spot. But could you imagine a mercury barometer filled with this, and that pressure is moving this around? Yes, I keep it in my office. So if you guys ever come to Phoenix, definitely would love to show it to you. Stratospheric ozone depletion. The stratosphere is an Earth security blanket. It is located about between 10 and 30 miles above sea level and is comprised of, among other things, ozone. An ozone molecule consists of 3 oxygen atoms. I'm going to have to take their word for it. That's why I went into air conditioning. Ozone protects us from harmful ultraviolet radiation, helps maintain stable Earth temperatures. Stratospheric ozone depletion is a global problem. Ozone depletion causes crop loss, increase in eye disease, skin cancer, reduced marine life, deforestation, and increased ground level ozone. CFCs and HCFCs, when released into the atmosphere, deplete the ozone layer. The chlorine in these compounds is the culprit. When a chlorine atom meets an ozone molecule, it takes 1 oxygen atom from the ozone. This forms a compound called chlorine monoxide and leaves an O2 molecule. I hope no one asks me, because I'm not going to be able to explain that. Other than people talk about the chlorine in their pool. Is it the same chlorine? No, because that chlorine is water soluble. Chlorine monoxide will collide with another ozone molecule. It releases it to the oxygen atom, forming 2 O2 molecules, and leaves the chlorine free to attack other ozone molecules. A single chlorine atom can destroy 100,000 ozone molecules. Ozone depletion, or ODP, is a measurement of CFCs and HCFCs' ability to destroy the ozone. CFCs have the highest ODP. HCFCs, or 134A, do not contain chlorine and have no ODP, even though R410 is on the hit list now and 404A is on the hit list, and probably one of the best gases still alive or around, even though it's not alive, is R12. Used R12 in air conditioning, automotive, refrigeration, medium temp. It's a fantastic gas, but it has a very high CFC count, as well as like R11. If you guys have ever seen R11 in a chiller, it has a very high ODP, but we used to use it in the old days for flushing acid burnouts and washing our hands in it, washing tools in it. R11 was a fantastic gas, and that is actually the precursor where you guys ever use an R11 flush kit. That's where the R11 flush kit originally got its name, is we used to use R11, liquid R11, and flush it through the system. That's how it got its name, those R11 flush kits. Three types of primary refrigerant is a CFC, R11, R12, R500, 502, 503, 507. Those are high CFCs. And HCFC is R22 and 123. And HFC is 134A, 410, and 404. Again, 134A, 410, this was done about 4 years ago. We know that R410 and 404A are on the hit list to be gone. The United States EPA Protection Agency regulates Section 608 of the Federal Clean Air Act. Failure to comply could cost you and your company as much as $27,500 per day violation. And there's a bounty of up to $10,000 to lure competitors, customers, and fellow techs to turn you in. Service technicians who violate the Clean Air Act provision may be fined, lose their certification, and may be required to appear in federal court. I know of a case in Southern California where there was a technician watching another technician across a rooftop who was intentionally venting. He took some videotape of it, went to the EPA, and made a good chunk of change. And that other technician and that company was fined. So it's really important, you know, when you're on a rooftop, you know, you comply by the law, you do all the recovery processes that you're supposed to. You just don't know who's watching you. Violations of the 608, falsify or fail to keep required records, fail to reach required evacuation rates prior to opening or disposing of an appliance, knowingly releasing or venting HCFCs, CFCs, or HFCs while repairing appliances, with the exception of de minimis release. De minimis is just what comes out of your hoses, things like that. Knowingly release or vent CFCs, HCFCs, or HFCs while repairing appliances, with the within the exception of the de minimis release, meaning bleeding off refrigerant, which we used to do in the old days. We used to take a system, we would bleed off refrigerant while the dryer is being changed, put the dryer on, connect everything up, bleed refrigerant through the dryer, tighten it up real quick, open the valves, let it go, as dumb as it was. And ductless split systems and VRFs and VRVs, they used to come with a static charge on the condenser. We would actually take and hook up the liquid line or the liquid line coming out. We would vent refrigerant all the way through the line, come back through the suction side, let it bleed out, put a little bit of oil on it, hook it right to it, tighten the flare, and call it good. We knowingly did that for years on Mitsubishi, Mr. Slims, and ductless splits in the early 90s. That's what they're talking about there. Vent CFCs, HFCs since July 1992. Vent HFCs since November 1995. Failure to recover CFCs, HCFCs, or HFCs before or opening of any appliance. Failure to have an EPA-approved recovery device equipped with low-loss fittings and register the device with the EPA. Add nitrogen to a fully charged system for the purpose of leak detection, thereby causing a release of the mixture. Again, we did this in the old days. It's my fault. So whatever you guys are having to do with recovery, you can blame the old guys like me, and just, you can send me emails and say I suck. Dispose of a disposable cylinder without first recovering any remaining refrigerant, and then rendering the cylinder useless, then recycling the metal. You definitely want to make sure that wherever the branches that you're at is that you're recovering if you're doing any transfer, or you're taking your bottles to RSD or air cold. They'll handle that for you. You don't want to handle that. But get with your individual service managers and your branch managers on what they would like you to do. Montreal Protocol is an international treaty that regulates the production and use of CFCs, HCFCs, halons, methanol, methyl chloroform, and carbon tetrachloride. Halon was actually used in computer rooms. In the mid-90s, I was doing lots of computer rooms and used halon as a way to combat fires in a computer room. It's just basically a big drum of R12, but it was horrible for the atmosphere. CFCs were phased out of production on December 31st, 1995. HCFC refrigerants are scheduled a phase out in the future. When virgin supplies of CFCs are depleted, future supplies will come from recovered, recycled, or reclaimed gas, or in my case, I've got 2 bottles of R12 sitting in my garage. Recovery: to remove refrigerant in any condition from an appliance or store it in an external container. Refrigerant that has been recovered from a unit, if it is not contaminated, may be reused in the unit in which it was removed. It also may be reused in another unit so long as the equipment that is removed from one and the unit to which it has belonged is being introduced by the same owner. This requirement is designed to prevent excess cross-contamination. We do that quite a bit here in Phoenix, and I'm sure all the other branches do too that are using the Mavericks. Here in Phoenix, we recover the gas from our Big Lot locations. We keep it in cylinders, we run it through, especially when they're taking and replacing equipment, and we'll reuse it again in other Big Lots. So it's done quite commonly. I'm sure you guys are doing it with the Mavericks. It saves the client a bunch of money. So get with your branch manager on that. Recycle is to clean refrigerant for reuse by separating the oil from the refrigerant and removing the moisture by passing it through one or more filters. Again, when you're going to do that, make sure that you're putting pre-filters on your recovery units like your Apions. They will actually burn up the seals if you're using bad refrigerant, or the oil will dissolve the seals and it causes unnecessary repairs. Reclaim is to process refrigerant to a level equal to new product standards as determined by chemical analysis. Reclaimed refrigerant must meet standards set forth in the ARI 700 before it can be resold. We return all of our gas here in Phoenix to Rapid Recovery, and Rapid Recovery will send out bills like this. It tells me all of the gas that was recovered, what we get for it on a return credit, and then we'll actually go back to Rapid Recovered and buy gas based upon what we have stored in our account. Refrigerant recovery or recycling equipment manufactured after November 1993 must be certified and labeled by an EPA approved equipment testing organization to meet EPA standards. There are 2 basic types of recovery devices: system dependent, which requires refrigerant with the system's components and the appliance from which refrigerant is being recovered, which we don't use too much anymore; or self-contained, which means which has its own means to draw the refrigerant out of the appliance or compressor. System dependent, again, we used to use the air conditioning compressor to pump the gas into a bottle. Once we got it down to a point to where I could use a different type of recovery, because the recovery units in the late 80s, early 90s were massive. Sometimes a couple of guys would have to rope it up on a roof because they were so heavy. They are not like they are today. Azeotropic refrigerants. An azeotropic refrigerant mixture acts like a single compound refrigerant over its entire temperature pressure range. An azeotrope does not have a temperature glide. Recovery customer relations. Some customers complained about the increased cost of service. To justify the increase, simply explain that you are duty bound and required by law to recover refrigerants in order to protect the environment. Most of our customers, if not all of our customers, know it already, and nobody's really complaining about it any longer. Mixed refrigerant. Do not mix refrigerants in a recovery cylinder. A refrigerant mix may be impossible to reclaim. Mixed refrigerants are destroyed. They can't reclaim them. If you discover that 2 or more refrigerants have been mixed in the system, you must recover the mixture into a separate tank. We don't do that here. We just we actually label the bottle as mixed gas, and we let rapid recovery take care of it. Badly contaminated mixed refrigerants must be destroyed. So really make sure you get with your branch manager if you're needing more bottles, because we do not want to mix gases. It's very costly to the company and to the client. A strong odor is an excellent indicator of a compressor burnout. If you suspect a compressor burnout, flush the system and watch for signs of contamination in the oil. If nitrogen is used to flush debris out of the system, the nitrogen may be vented. A suction line filter dryer should be installed to trap any debris that may damage the new compressor. This is simple stuff. You smell the refrigerant. When it burns the inside of your nose and your eyes water, you know you got a bad thing, bad gas. Or you can use a refrigerant test kit and do an oil sample. Long hoses will reduce pressure, resulting in increased recovery time. Since all refrigerants have a pressure-temperature relationship, lower ambient temperatures result in a slower recovery rate. Obviously, you guys know that already, especially you guys living in the northern states, you know about it. If moisture is allowed to remain in an operating system, hydrochloric and hydrofluoric acids may form. Evacuation of the system is a suggested method of dehydration. It is not possible to over-evacuate a system. We both know, all of us know that. You can double, triple evacuate. You can get down, we're seeing micron levels in the hundreds, so it can never be too low. Never evacuate a system to the air without first following proper recovery procedures, attaining the mandated vacuum level. Vacuum lines should be equal to or larger than the pump intake connection. Most guys, even though there was just a poll done on social media that said 61% of the techs polled are still running their vacuum through their manifolds, which a lot of guys are switching over to a charging tree. They're building a charging tree and they're running it off, not through the manifolds, but through, you know, like pipe connections. They're seeing faster recovery in evacuation times. Evacuation, the piping connection to the pump should be as short as length as possible and as large as diameter as possible. The system evacuation gauge should be connected as far as possible from the vacuum pump. How many times have you guys seen the micron gauge is right up against the pump or on the pump? I used to do a lot of built-up work on 60 tons, 100 tons, 200 ton built-ups. We would actually braze in out at the evaporator coil and access port and attach the micron gauge there. And then our vacuum pump would be on the roof and it could be 40, 50, 60, 100 feet away. It would take longer, but we knew that if we had a really low level under 500 microns out at the evaporator coil, that we were definitely in a good spot. Evacuation factors: size of equipment being evacuated, ambient temperature, amount of moisture in the system, the size of the vacuum pump and the suction line. Obviously, what you're going to get out of a small Robin Air vacuum pump compared to, if you guys doing markets, what you're doing with the belt-driven vacuum pumps, you're going to get a greater pull out of a belt-driven pump. But again, it's all on the hose size. You guys know this already. Precautions: the use of a large vacuum pump could cause trapped water to freeze. During the evacuation of the system with large amounts of water, it may be necessary to increase pressure by introducing nitrogen to counteract the freezing. That's where we get into double and triple evacuations. Dehydration measuring. This is in your, you can take a picture of this or use this later on. If you want me, you can actually go back and grab some of this on your own. Recovery cylinders are designed to be refilled. Recovery cylinders having two ports, one liquid, one vapor. They must not be overfilled or heated. Overfilling or heating can cause an explosion. Never heat a refrigerant cylinder with an open flame. The EPA requires that refillable refrigerant cylinders must not be filled above 80% of their capacity by weight, and that the safe filling level can be controlled by either mechanical float devices, electronic shutoff devices, thermistors, or weight. Refillable cylinders must be hydrostatically tested and date stamped every 5 years. Of course, if you guys are going and doing a bottle exchange, they're going to take care of that for you. And there back in the day was a recovery system called an OZ Saver, and they actually had to use their tanks, and they had it a weight on the inside with a cable, and it would fill up to the point and actually cut off the recovery unit. Refillable cylinders used for transporting transporting recovered pressurized refrigerant must be DOT approved, which they are. That handled by our recovery company. Approved refrigerant recovery cylinders can be identified by their yellow top and gray bodies. All refrigerant recovery cylinders must be inspected for rust. If they show signs of rust or appear to not be secure, they may reduce to 0 psi and discarded. Disposable cylinders are used with virgin refrigerant and may be never used for recovery. So you guys have ever seen the top of the little recovery or the disposable cylinder? It's got that little top. That's actually a little pressure relief. We do not want to use them. They're not designed for it. It is necessary to inspect the Schrader valve cores for leaks, bends, or breakage. Replace damaged valve cores to prevent leakage. Always cap Schrader ports to prevent accidental depression of a valve core. That is you guys definitely don't want to drive down the road without those caps on. When handling and filling refrigerant cylinders or operating recovery or recycling equipment, you should wear your safety glasses and protective gloves. If you guys know anything about, if you've seen it, I've actually seen guys that have had to go to the hospital with third-degree burns on their hands because the hose blows during recovery and they get a liquid refrigerant burn. It's horrible. It burns the skin just as bad as a flame. Pressurizing the system with nitrogen, you should charge through a pressure regulator. Insert a pressure relief valve in the downstream line from the pressure regulator. Never install relief valves in series. You don't want one blow into the next one. Stupid. Replace the relief valve if corrosion is found within the body of a relief valve. To determine the safe pressure for leak testing, check the data plate for the low side pressure, test pressure value. So again, I'll look at an evap coil, look at it, see what the test pressure rated is, because I don't want to blow an evap coil in a market case or in a Maverick if I've exceeded the test pressure of that coil. When leak checking the system, never pressurize the system with oxygen or compressed air. When mixed with refrigerant, oxygen or compressed air can cause an explosion. If you want to go on YouTube, there is a video out there that I saw a couple weeks ago of a guy pressure testing with oxygen on a VRF. I think it was in India, and it blew him apart. It was a horrible video to see, but they used oxygen to test, leak test a VRF, a little ductless split, and my gosh, it was horrific. So, you know, we don't want anything to happen like that to you guys. If a large release of refrigerant in a confined area occurs, self-contained breathing apparatus is required. If SCBA is not available, immediately vacate and ventilate the area. In large quantities, refrigerants can cause suffocation because they are heavier than air and displace oxygen. Inhaling refrigerants or mist may cause heart irregularities, unconsciousness, oxygen deprivation, leading to death. Refrigerant techs will be in a motor room. The refrigerant blows. They try to stop it. The refrigerant is inhaled. They get dizzy. They pass out. They fall to the floor. And that's because refrigerant is heavier than air. It actually pushes the oxygen out, and the technician dies. It's really fast. So if it blows, get out of the area, your life is not worth trying to save $100,000 worth of ice cream. We value you way more than ice cream. Never expose R12 or R22 to open flames. A glowing or hot metal surface at high temperatures, R12 and 22 decompose from hydrochloric and form hydrochloric acid, hydrofluoric acid, and phosgene gas. You guys know once you get that smell of phosgene, you never get it out. Always review the material safety data sheets, MSDS, when working with solvents, chemicals, or refrigerants. If you're unsure about what you have, most of us buy our supplies from RSD or other supply houses, and they will have the MSDS for the chemicals that you're working with. Before shipping used refrigerant cylinders, complete the shipping paperwork, include the number of cylinders of each refrigerant, and properly label each cylinder with tape and the amount of refrigerant. Cylinders should be transported in an upright position. Each cylinder must have a DOT classification tag indicating it is a 2.2 non-flammable gas. Some states may require special shipping procedures to be followed based on their classification of used refrigerants, checked with the DOT in the state of origin. The market, guys, when we're buying refrigerant in 125-pound cylinders, we're most likely going to have them laying down in a horizontal position, so please make sure those caps are screwed on the end. I've seen video and personally seen what happens when a nitrogen tank and a refrigerant tank breaks off the end. It becomes a very long-range missile which can kill. Equipment manufactured before 1993. This is old and new recoverant. Must be capable of removing 80% of the refrigerant, whether or not the compressor is operating, or achieve 4-inch vacuum under the conditions of ARI, the American Refrigerant Institute, ARI 740. Equipment manufactured after 1993 must be certified by an EPA approved testing laboratory. Example, if a URL or ETL is capable of recovering 90% of the refrigerant, if the compressor is operating, 80% of the refrigerant, if the compressor is non-operating or achieving. I mean, quite honestly, we're all using brand new stuff. This kind of is an older code, but we're all using new Apions or whatever you guys use, and our new recovery equipment is definitely able to pull that. ABCs. A is after November 15th, 1993. B, before November 1993. C equals non-operating compressor. Again, this is for you. A, after 1993, 4 inches of vacuum or 90%. B, 80% or 4 inches of vacuum. Or C, non-ops, 80% or 4 inches. Again, I've never even seen this, because our new equipment today definitely pulls that. Do not recover refrigerators built before 1950, as they may have used methylformate, methylchloride, or sulfur dioxide as a refrigerant and should not be recovered with current recovery devices. It also applies to small appliances used in campers or other recreational vehicles that may use refrigerants such as ammonia, hydrogen, or water, therefore should not be recovered using current recovery equipment. I haven't seen an air conditioning unit since 1950. So I guess they're out there, but you really want to know what you're working on before you do, because that would be explosion and death, and we don't want anything to happen to you. Leak detection after installation of the system. Pressurize the unit with nitrogen and leak check. In order to determine the general area of a leak, use an electronic or ultrasonic leak detector. To pinpoint the leak, use soap bubbles. It's pretty standard. EPA regulations require that all comfort cooling appliances or air conditioning containing more than 50 pounds of refrigerant must be repaired when the annual leak rate exceeds 15%. Again, that would be in our supermarket systems where maybe we've got an air handler tied to a rack, or a large buildup on the roof on older market systems where you've got some 60-ton, 30 or 40 or 50-ton, 60-ton condensing units tied to an air handler, you could have up to over 50 pounds of refrigerant. Leak repair and commercial industrial refrigeration. EPA regulations require that all commercial industrial process refrigeration containing more than 50 pounds of refrigerant must be repaired when an annual leak rate exceeds 35%. Anybody doing markets? I would assume everybody's doing markets. Idaho Falls and Sean's group is definitely doing some market work, so this would apply to them. You know, the other branches, Salt Lake City, I know St. George is doing markets, Las Vegas is doing markets. You know, this definitely applies to them. Commercial industrial refrigeration, leak repair. Commercial refrigeration includes appliances used in retail food, cold storage, warehouse, including equipment like we talked about, supermarkets, C-stores, our Circle K's here in Phoenix, and our Mavericks elsewhere. Restaurants in Denver, they do a lot of Cheesecake Factory, other food establishments and equipment used to store meats, produce, dairy products, and other perishable goods. Industrial process refrigeration, meaning complex, customized appliances used in chemical, pharmaceutical, petrochemical manufacturing, including industrial ice machines and ice rinks. We have one here in Phoenix. Basically ammonia systems, large R12 systems. Recovery notes. Refrigerant should be placed in a receiver of units that have receiver storage tanks. I'm sure guys are pumping down. I'm 100% confident that the Idaho Falls guys are pumping down refrigerant into the receivers when they make their repairs. Refrigerant should be removed from the condenser outlet if the condenser is below the receiver. That makes sense? I haven't seen many of those, but I'm sure they're out there. In a building that has an air-cooled condenser on the roof and an evaporator on the first floor, recovery should begin from the liquid line entering the evaporator. That's where the refrigerant is going to stack. Usually it's going to stack up against your solenoid valve. I'm not going to go through all of these notes. You guys can read through them. Probably take a picture if you want to. Appliances isolated, HCFC, manufactured before 00. That looks like the recovery notes. HFCs isolated. That is your, I'm not sure what that is. What is that? You guys can unmute if you want. I think they're talking about the vacuum levels. Looks like the vacuum levels. Under EPA regulations, a major repair means any maintenance, service, or repair involving the removal of any or all of the components, compressor, condenser, evaporator, auxiliary heat exchanger coil, meaning like a subcooler would be an auxiliary heat exchanger coil. To determine the type of refrigerant used, read the nameplate or your PT pressure temperature chart. Filter dryers will remove moisture from the refrigerant in a system, but there is a limit to their capacity. Some systems are equipped with a moisture indicating sight glass. When the sight glass changes color, the system contains excessive moisture and will need to be evacuated. There are some sight glasses out there that have no indicator. They're very old systems that actually had a sight glass on one side and a sight glass on the other, and you put a flashlight in the back, and that's how you check your liquid level. So you have to make sure of that. The filter dryer should be replaced anytime a system is open for being serviced. Hermetic compressor motor windings could be damaged if energized in a deep vacuum. Never energize a recip if the discharge valve is closed. Big bada boom. Big boom. If a system is suspected of water tube leaks, the water side of the system should be drained prior to recovering the refrigerant. When vacuum testing a system, if the absolute pressure rises above 1 psi, 1 inch of mercury at any point, the system should be checked for leaks. System oil should be heated to 130 degrees prior to draining to ensure the release of refrigerant from the oil. You guys see that when you pull a vacuum and the oil is cold, you can actually watch the refrigerant bubble out of the oil. And then the old term used to be called blank off. We would blank off a system in a deep vacuum and make sure that it does not rise above a certain point. Guys that are doing Walmarts, they know all about blank off because they have to do that before Walmart will approve a system start. System pressure should be monitored after evacuation for a few minutes to ensure the max amount of refrigerant has been removed. If pressure rises, recovery must be repeated. Systems that cannot attain or maintain a stated level of evacuation should be evacuated to the highest possible level prior to repair. So again, we're looking to see if any refrigerant rises after you pull it down. If it kind of starts to float back up, you've got additional refrigerant that you need to pull out. Freezing water must be avoided. If necessary, use nitrogen to accrete. Again, that's your blank off. Strong odors and contaminated oil is a possible indication of compressor burnout, which we know. I'm sure a bunch of guys have smelled that acid and had their entire nose catch fire because it smells so bad. Purge unit. The purge unit operates with suction from the top of the condenser. It removes air, moisture, and other non-condensables. If the frequent purge operation occurs or excessive moisture is detected by the purge unit, it may be leaking. The only time I've ever seen purge units is when I did centrifugal chillers. Back in the day, there would be a purge pump on the side of the chiller. If you guys have seen them elsewhere, you can go ahead and unmute and let me know. But centrifugal chillers, absorption chiller, not absorption, but centrifugals, recip chillers will have a purge pump, and they want to get that. They'll see the non-condensables, they'll come on, condense, and purge the moisture out. Safety, equipment rooms must be monitored for high refrigerant levels, in which a case an alarm must be sounded, and the system must be automatically, ventilation system be automatically activated. I've seen that a lot in Albertsons locations. It's got that little refrigerant sensor on the inlet side of an evap condenser fluid cooler. So it's monitoring the intake, especially when the evap condenser is inside the store or inside the mech room. You'll see it there. Ashrae standard 15. You have to follow that for all Ashrae refrigerants. All refrigeration systems must be protected by a pressure relief. Never install pressure relief in series. Has anyone seen a pressure relief blow or been inside a pressure motor room? Anybody? You guys can unmute if you want. No, it's really loud. I had a pressure relief blow in Southern California. It was in the motor room. I took the technician's word for it that everything was working properly. He'd actually jumped out some safety switches that I didn't know as we were charging, and we exceeded the pressure in the receiver. Again, I took his word for it, and I blew probably a couple of 100 pounds of R22 until the pressure relief reset. We had to pull all the gas out, isolate the receiver, replace the pressure relief, because this pressure relief did not have the little front seating valve on it. It was actually screwed in right into the top of the receiver. These are higher flammability rates. Not sure what that means. Oh, HCFC, CFC 11, 134 are classified as an A1, so they really don't have any flame. 123, I would assume these A3s and Bs up here would be like R12s and stuff like that. Any questions? Any questions? So there's going to be some changes in 2019. If you want a copy of the changes for 2019, I'm going to give you my email. It's mmayberry, M-M-A-Y, B-E-R-R-Y, at customcooling.com. So mmayberry at customcooling.com, C-O-S-T-O-M COOLING.com. mmayberry@customcooling.com. And I will email you over the changes for 2019. Some of the changes are going to be that the updated 608 will include new leak detection, inspection, and verification test requirements for technicians starting as technicians after 2019. Leak inspections are required for appliances that have exceeded the applicable leak rate. There's going to be some changes as far as testing for verification. An initial verification test must be performed before any additional refrigerant is added to a system. So the old days when a system was low on gas and we're going to top off, they're going to require that a complete leak detection is done on the system. Leaks are fixed before you top off the refrigerant. A follow-up verification test must be performed only after the appliance has been returned to normal operating conditions. So if you make a system, you do a leak, you fix the leak, you replace a compressor, they're going to require that a leak detection be done after the repair is made. So even if you have a cracked liquid line, you fix the cracked liquid line, you top off your refrigerant, then a whole new leak detection is going to have to be done on the entire system to verify that it is leak-free. On supermarket refrigeration, it's going to be from 50 to 100 pounds once per calendar year until the owner-operator can demonstrate through leak detection rates has not exceeded 20%. So they're going to fine-tune you guys down. You're going to have to keep doing leak detections until you get that system sealed and that your leak rates are under 20%. So there's going to be some changes in 2019. You definitely want to check them out. There were some changes in 2017. There was some no stuff in here about that you needed your license for 3 years. So if you guys decide to get out of the trade, you have to keep your EPA license for 3 years after you've left the business or you've retired. So just when you think you're out, you're not really out. Okay, so is there any questions about today's EPA discussion? Again, mmayberry@customcooling.com. I can send out some stuff. I'll send some stuff out to you guys if you want that shows the new stuff that's going out in 2019. The next class will be, you have your calendar, will be on 12/11. That's going to be HVAC and heat pumps. Looks like tomorrow you have your advanced training with diagnosing AC and refrigeration systems. Jim's got a supermarket refrigeration class coming up on December 6th. And then Scott's got a controls class coming up on Friday. As always, I appreciate you guys. Solder Weld is my sponsor. We got some cool stuff going on with Solder Weld. If you have any questions, you have my email. If you need to get a hold of me direct, you can call me on my cell phone, 909-900-9540, 909-900-9540. Hope you guys have a great week, and we'll see you next time. If you have any questions, now's the time. Now's the time. Anyone? Okay.
Hey, just wanted to say thank you.
Yeah, no problem, bud. Appreciate you. All right, you guys. Have a great week.